this video will be going over Unit 5, Lesson 7 Practice, which is the Unit Assessment Review. So let's get started. Number 1 says that we have a function f of x is equal to 3 times 5 to the 2x minus 3, and it wants to know whether that's an exponential function. And so it's asking us to get it in the format that would show that it's exponential if that's the case. So let's do that. We would start by realizing that some of our Algebra 2 skills are going to come into play here. Okay, the first step that I have is that I can rewrite that 5 to the 2x minus 3 as two separate bases of 5 separated back out. Back in Algebra 2, we used to combine the two exponents with the same base. Now we're kind of undoing that. The next thing that I notice is that 5 to the negative third power is the same as 1 over 125. So I'm going to just bring the 1 over 125, kind of dealing with multiplying by the 3 out here. Now we're to 3 over 125 times 5 to the 2x. Now I also remember something from my exponent rules, which says I can square a 5 and get 25 and still have that x up in that exponent. And so this does satisfy that format of being a times b to the x. So it is exponential, and the format would be answer choice C. All right, let's look at number 2. Number 2 asks you which of these transformations is really going to take you translated 2 units right and horizontally stretched. So before I do this, I'm going to undo the drawing command for just a second to allow you to click the link on the cheat sheet, Transformations cheat sheet. Okay, click that link. Then I'm going to go back to the draw screen, which won't allow you to do that. All right, so taking a look at that, I am looking specifically at the lines that talk about going right C units. That's the 4th line down. Okay, so that has the f of x minus c line is where we're interested in because we want to go right 2 units. And we want to be horizontally stretched by a factor of 4. So we're looking for horizontally stretching, so we're looking for the f of ax on your chart, where a is between 0 and 1. Okay, so we're looking for those things to happen. So first of all, I notice my parent function, or f of x, is 3 to the x. Okay, so we're involved in dealing with this exponent here. So let's start at the bottom and go our way up here. So I'm going to start with 3 to the, I'm going to factor out a 4 there and have an x plus 2 going on there. I want you to notice that this has x plus 2, which actually means 2 units left, so he's not a winner. Okay. Next, I'm going to go up here and do the same thing, factoring out that 4 and getting an x minus 2. Okay, so we've gone 2 units right because of the x minus 2. Let's talk about this 4 out in front of here. The 4 out in front of the x needs to be between 0 and 1. 4 is not between 0 and 1. Not a winner. Okay, so let's go up to A, since we're running out of room. And we're going to factor out a 1/4 in front, and we're left with x minus 2. If you're questioning how I got the minus 2, think about if you distributed this 1/4 through, you'd get 1/4 x, and you'd get minus 2/4, which is 1/2. And so we've got the right 2 units taken care of there. The right 2 units taken care of there, and the 1/4 that needs to be between 0 and 1. So I would pick answer choice A. Okay. Number 3. Number 3 says, which of the following equations will be that written in exponential form? All right, so the first thing that I realize is, or should know, is that the natural log, its inverse, or its exponential pair, is an e. Okay, e is the natural logarithmic constant. So I'm going to exponentiate, that's what that's called, both sides of this equation, saying e to the natural log of 2 and e to the 3x plus 1. Now, knowing what you should know is that the e and the natural log are inverse operations of one another, leaving me with just 2 is equal to the e to the 3x plus 1. And so I would say answer choice B there. The next one, which term is bigger? So this, to me, is a calculator question. It's going to be put in, I put it in Desmos in mine. And when you go to Desmos, you should be picking underneath the functions. There's a place to click for functions. Go up to miscellaneous, and then choose the general log base. There's one that has a little log base A that allows you to put in the 25 and the 16. And then, I mean, it's just a matter of comparing those numbers. So I'm noticing that negative 2 would be less than negative 1.5 if we think about a number line. And so that means answer choice D is happening, because that means log base 25 of 1 over 625 is less than the other one. All right, next one. Number 5. Another transformations question, and it wants us to compare the graph and find that transformation. So pulling open that transformations cheat sheet again that I had you open earlier, we are going to be in the line of we want the f of x minus c, because that's what we have going on here. So we want the f of x minus c because of the x minus 5. We change colors here. We want to think about the a f of x, a times f of x line. Okay, that's related to this. And also the negative f of x line, which is related to that negative right there. So the negative f of x. So there's 3 things going on here. Okay, let's talk about the yellow one first, the negative. The negative f of x, if you'll look at your table, reflects over the x-axis. Okay, so right off the bat, I know I'm either C or A right now because of the reflection over that x-axis. Let's go to the maroon colored item, where A is 2 in this case. So A is bigger than 1. A is bigger than 1, so we've got to stretch vertically by a factor of A. So if we're stretching vertically by a factor of 2, well, both of those had that. We weren't able to distinguish anything from that. Now finally, the last thing, the x minus 5 piece. If we look at f of x minus c, that says that we are moving right 5 units. Okay, so I'm going to pick answer choice C there. All right, on to the next one. Which of the following is the graph of that function? This is a Desmos question. So if you put it in, again, finding under functions, miscellaneous, the general log, you could put in log base 3 of x plus 2 minus 1 and pull up that graph. You should pause and practice that for yourself. But when you do, you'll find the answer choice on your review is answer choice A, that matches your graph. Okay, next one. Number 7. We're going to rewrite this logarithmic expression into a single log expression. So there are a couple of rules, actually 3 rules that'll be perceived here. The first is when you've got a number in front, he can become an exponent on the back end there. So my first step would be to have a log base 3 of x plus 1 cubed minus a log base 3 of x squared, bringing that exponent up, minus log base 3 of x minus 6. The next rule for logs is that you can look at subtraction as division. Okay, if there was multiplication involved, there would be an addition sign between these. Okay, so what happens is I can condense this into 1 log base 3 with its numerator being x plus 1 cubed, and the two denominators, because they're both subtraction, that means they both belong down in the bottom, as x squared and then x minus 6. And so when I notice that, I see answer choice B as they distributed the x squared through the denominator. So I choose answer choice B. All right, use your calculator to approximate. Again, Desmos will help. I found, though, on this one that I had to, in addition to going and getting the log with the general base, I actually had to change 6/5 into a decimal for some reason. I couldn't get it to put it in as 6/5 there. So I just made that into 1.2 and then entered my log. Log base 1.2 of 6.8 got me 10.513 ... And that leads me to answer choice D. All right, finding a zero. This looks complicated, but the concept is the same that it's always been. If I ask you to find a zero, I'm asking you to find where the x-intercept is for this function. So I'm going to graph 2 to the x minus 1 minus 3 to the x plus 1, and I'm going to see where it crosses the x-axis. And if you'll put it into Desmos, you'll see a little gray dot if you'll click on the actual Desmos screen. And it'll pull up an ordered pair. Pulls up that ordered pair of negative 4 point something, negative 4.41 I think, comma 0, telling you that's where the 0 is. Now the challenging part now is to look at these answer choices and say, well, which one of those equals negative 4.41 ... Okay, so I had to do a little bit of guessing and checking, and I did that and found that answer choice A comes out to be the same as that numeric option. So graph it, find its x-intercept, and then you just have to find out which one's equivalent. Again, looks maybe more challenging if you didn't have Desmos to use. Next one, number 10. Number 10, we are going to solve for x, and so it's going to take some of our log rules. The first thing I'm noticing is that subtraction that we talked about a second ago can become a singular log with a division because of that subtraction. The next thing we need to know is how to go from exponential to log or vice versa. And in this case, taking it into an exponential form is how we're supposed to do that. And so we take and say 8 to the 1/3 power must equal x plus 1 over 3x. Okay, 8 to the 1/3 power is 2. All right, that's like a cube root of 8. Then I would multiply both sides by 3x, running out of room here. So I get 6x is equal to x plus 1. I would subtract the x from the other side and get 5x is equal to 1. And finally, divide by 5. X equals 1/5. I choose answer choice C. All right, number 11. Number 11 asks us to find some functional values, f of negative 2.9 and f of 0. With these piecewise functions, the key is getting in the correct piece. So the first thing I'm going to note is that f of negative 2.9 means I need to be in the window where negative 2.9 is. And that is the second function. And 0, I need to make sure I have the correct window for that as well. And I would be in the third window because of 0 less than or equal to x, meaning it's included in that piece. So that is just a Desmos issue. You're going to pop them in and evaluate them and pick your answer choice. So I get answer choice D. All right, we're now going to look at a piecewise graph and figure out which one actually matches this. And so this looks really messy at first. I'm going to focus my energy over here at this parabola piece, okay, the first piece. And I notice that its vertex is at -3, -2. Now, when I look up at answer choice A, that vertex is at -3, +2. When we're talking about a vertex, if you graph this, it would be at -3, +2. Now, B and C and D each have them at -3, -2. Okay, so we now know A is not in our answer choices. The next thing I want you to note is when I come over here, I see a linear piece, and I see a y-intercept of about 1.5 or so. And according to these, I'm looking at this second piece. Well, I need +1.5, which means this one can't be it because it has -3/2 there. Okay. So then I head towards the other piece, trying to figure out what's going on here. Is there a difference between B and C? That's what I'm also looking for. So I do notice, I don't really notice a difference between B and C too much. I know I got the answer choice B. Let's look a little closer here. So I know the first piece matches up. Second piece is identical as well. Well, is it? Let's go back. Yeah, I think that's the key here. This linear piece starts at -2 exactly. And so this domain includes -2 in that linear piece. Look at answer choice C. It says we didn't quite touch -2. Okay? And so that's why I would get rid of answer choice C. And finally get B. Took me a minute to look through that. All right, solving, number 13. Number 13 has an e to the x minus 24e to the x. When does it equal -2? Again, I think a visual is good. I think graphing the two pieces is good. So I graphed the e to the x minus 24e to the -x, and I graphed -2. And then I zoomed in enough to see where I'm looking. I'm looking for the place where they cross. And so when I click on that point, I see a value. And what happens is I don't even really need to look too much closer because I'm looking for a positive value there. So in your calculator, you could figure out which one of these is a positive value. First of all, I would definitely say D is not a positive value. We didn't get two different values, so I'm not going to say C. And then I would just put natural log of 4 and then the other one in and see which one worked to be that point of intersection. Next one, solving that equation. Solving that equation requires us to take it out of out of logarithmic form into exponential form a couple of times. So I'm going to first start with 27 to the 1/3 power is equal to log base x of 10. Then I realize that 27 to the 3rd is like cube root. So cube root of 27 is 3. Now I see another chance to go into exponential form. So I say x cubed is equal to 10. And solving that requires a cube root of both sides here to get the x alone. So I'm going to cube root the x cubed. I'm going to cube root the 10, allowing us to solve for x and getting x equals cube root of 10. All right, next one. Graph the following piecewise function and determine the number of discontinuities. Now you don't have to absolutely graph it. we could just check the breaking points, and that's what I'm going to do. I'm going to plug in -2 into this piece and this piece and see if they match up, because those y values have got to be the same as we break apart the different pieces. Then I'm going to put 1 in there and 1 in here. And then I'm going to put 2 in here and 2 in there. Okay, so we're going to have 3 different operations going on here, trying to see if they're equal. So -2 is going in there. I'm doing 1/2 times -2 plus 3/2. I'm trying to see if that's going to equal e to the -2 plus 1. Okay, so if I multiply 1/2 by -2, I get -1. -1 plus 1/2 gets me 0.5. And this is the same as e to the -1, is it? If you put into your calculator e to the -1, you're not going to get 0.5. Okay, so we are not continuous at -2. So I know I have one discontinuity already. Okay, that one's discontinuous. So now I'm going to put 1 in the second piece. Let's change color here. So 1 is going in that second piece as e to the 1 plus 1. Does that equal 1 plugged in the second piece? 1 plus 2 squared minus 3/2. So this is e squared. It's kind of a yucky decimal if you put it into your calculator. And this is 3 squared is 9 minus 1/2 is 7/2. I know that e squared is not going to be a nice number, 7/2. Okay, so our second discontinuity is happening in that second piece. Okay, change color again. We're going to put 2 in that piece. So we've got 2 plus 2 squared minus 3/2. We're trying to see if that equals 2 plugged into the other one. So log base 10, that's that common log, of 6 minus 2. So this one's going to be 4 squared minus 1/2. Again, gets me 2.5, I think. No. 4 squared is 16, sorry. 4 squared is 16 minus 1.5 is 14.5. 14.5, does that equal log of 4? So we're going to have to check all of these. According to the answers, it says that we have 2 discontinuities. So when I go back and check those answer choices, I get that there's 3 discontinuities. Doesn't quite match up on either of the pieces, on any of the pieces, excuse me. So I say that that answer choice is incorrect there, and that it should be 3. Okay. Finally, the last one, we're going to expand that log using the properties of logarithms. The first thing I notice is that I've got a square root, which should trigger a 1/2 power. So the first thing I'm going to realize is that I've got a 3x divided by 4x squared minus 9 raised to the 1/2 power. Now I also want to remind you that that means that that 1/2 can come down in front. One of our log rules says it can come down in front. And so I notice that in kind of each of them. There's a 1/2 in front of the entire expansion. Okay. The next thing I want you to notice is this division going on. Division implies subtraction. So I also see within this numerator 3 times x. So that product becomes a sum. Okay, so I'm leaning towards actually answer choice D. Let's see what's happening here, because this one wasn't fully expanded and this isn't correct. You can't separate them like that. This one doesn't have the half all the way through it. Okay, so I'm not even going to look at that one. So let's see, we have 3 and x, that's the product piece, and then it said subtracting each of these 2 things. Realize that when it used to be 4x squared minus 9, when it's FOILed out, that's what it would be. So that answer should be answer choice D. All right, that's the end of the review. If you have any questions, send me a webmail or a text. Thank you very much.